Good morning, everybody. I am Boelo Schuur, Scientific Vice President of the European Federation of Chemical Engineering, the EFCE. I have been in the board of the EFCE since January last year. Now, I'm a chemical engineer by training. I received my degrees from the University of Groningen in the Netherlands, and I built my career in academia. Since 2011, I have been working at the University of Twente in the eastern part of the Netherlands, where I'm currently a full professor and my chair is called Sustainable Separation Technology. I'm very happy to be involved in the introduction of this webinar on sustainability, specifically the European Sustainability Framework and tools to deploy safe and sustainable by design principles, SSBD. I'm looking forward to participate in it. My role is to introduce the Spotlight Talk concept and the EFCE, which I will now do. Let's start with the Spotlight Talk. This is the 6th year that we organize this series of Spotlight Talk sessions. And after the COVID pandemic, we have decided, based on the success of these sessions, to maintain the Spotlight Talks on the calendar. Every year in the spring, we have a session. And this year, since from 8th to 10th of September, we have the European Conference on Chemical Engineering, ECCE ECAP in Lisbon, and there is only a spring session. And next year, we will have again a spring and a fall session. So for this spring, we will have 10 Spotlight Talks organized by 11 of our working parties and sections. So some of them do this together. And this includes chemical engineering applied to medicine, sustainability, chemical reaction engineering, process intensification, communication and classification, mechanics of particulate solids, fluid separation, polymer reaction engineering, static electricity, crystallization, and finally, early career chemical engineers. From yesterday, the 14th of May, throughout the 22nd of May, we may enjoy these short sessions of 3 or 4 talks organized on a specific topic by leading industrial and academic experts. The complete program is available on the EFCE website, efce.info, and you are encouraged to explore the other sessions as well. The EFCE promotes scientific collaboration and supports the work of chemical engineers in 30 European countries. And we represent more than 100,000 chemical engineers through Europe. EFCE's working parties and sections cover all the major topics and are the core of our organization. They form the scientific engine that drives many of the EFCE activities. They provide an important forum for technical exchange and networking among chemical engineers in Europe. In each of our working parties and sections, highly skilled engineers gather. Also on our website, efce.info, you can find information about these scientific groups. And I would like to invite everybody to have a look at the website and to explore our scientific groups. Maybe you are interested in joining one of our sections, such as the sustainability section that is organizing this Spotlight Talk. And joining a working party is on invitation only. But if you see that your country is underrepresented and you feel that you are a potential representative, or if you know a highly skilled individual in that domain of chemical engineering, please reach out to us and to your national member association to discuss options to fill up our working party if that is not complete. Well, before concluding, I would like to thank all the people who have worked hard inside the working parties and the sections of the EFCE to make this spring session of Spotlight Talks happen again. And in particular, I would like to thank Martina Poo for organizing all the practical activities and also conceptualizing and setting up again another wonderful series of Spotlight Talks. I thank you for your attention, and I wish all the speakers and the attendees a fruitful and successful webinar. I give the word to Antonis Kokossis, the chair of the section Sustainability, to chair this session and to introduce the first speaker of this webinar. Antonis, the floor is yours.
Thank you very much, Boelo. I'm Antonis Kokossis, chair of the sustainability section. My CV is on the web, so I am skipping all about myself to jump quickly and welcome you into yet another Spotlight seminar of the sustainability section, a newly established section, but one that enjoys a strong stream of topics. Last time we started with chemical recycling of plastics and renewable kind of plastics. We continue with education. We have been inundated with requests for future topics, also to bring the community together. And the Spotlight seminars are doing a great job. Again, I would like to also thank Martin for that. In the pipeline, just to let you know that we have topics that relate to renewable energy sources, carbon capture and e-fuels, biorefineries based on lignocellulosic, oleochemical, and algae, waste to energy and circular economy, social engagement, social LCA, data engineering applications related to KPI, new means, of measuring LCA, you may say, and a relevant and complementary concept to conventional sustainability and LCA-based kind of analysis is the concept that we address today and tomorrow. This concept of safe and sustainable by design. Safe and sustainable by design is a flagship, actually, framework that has been pioneered, promoted, and supported by the European Union to ensure that chemicals, materials, and products are developed and used in ways that are, both safe and for human health and the environment, and sustainable throughout their entire life cycle. And the key principles, that have been identified include prevention. So, in other words, or an oriented approach. Potential hazards, sustainability issues are identified early in the design phases. Safety, to avoid unacceptable risks in the ecosystems. Sustainability through life cycle, so that reminds of the conventional LCA. You may say that LCA then is part of SSBD. Integration into innovation, that means, clean technology and sustainable industries. And another part, transparency and responsibility, which is a very kind of promising kind of topic to involve digitalization, data engineering. Now, each different supply chain may be more or less separated, may be more or less prepared to address these kind of issues. And the two major initiatives, have been proposed to address the topic. One is an IRIS project. Many of our speakers, would come from that. And the other one is PARC. And one other speaker would come from that, and the different supply chains that have been analyzed and studied, from this kind of projects related to chemicals and materials, pharmaceuticals, consumer products, industrial process, and packages. So we come to our program today, and it is my real pleasure to introduce Andreas Falk from the BioNanoNet network, one of the most, if not the most active and dynamic network in Europe. And Andreas is the coordinator of the cluster, coordinator of the Austrian National Technology Platform. He has also presiding, if I'm as the director of all NTPs, quite recently driving SSCAM initiatives in this area. And he's also a plenary member of ISOTC 229. And since the inception of SSCAM Europe, he has been actively involved in shaping up strategies for the implementation of the SBD concept. Yeah. To that purpose, I would like to the invitation, and please feel free to update, share with us the presentation. Thank you. Andreas, you are muted. Thanks.
Okay, now I made it to unmute myself. Thank you, Antonis, for the nice introduction. As he said, I'm the CEO of BNN, it's BioNanoNet Forschungs GmbH, located in Austria. And it's my pleasure to present today at the EFCE Sustainability Spring webinar. My talk will be about the ecosystem for the implementation of SSBD, including the NSC, IRIS, and InnoMatSyn projects. And I will try to be very concise to give you the introductory part of where do we start from, where do we go through at the moment, where will we end up in the future, and where SSBD is well connected in this all parts. As later speakers will go more into the details about SSBD itself, I don't need to tackle it in a certain extent, so I can focus really on the ecosystem. All right, to set the scene, I try to start with some kind of background, which should be helpful that we can speak about the same things in this meeting. As already visible in the name of our organization, BioNanoNet, we have a certain part in the history in the nano field, and this is specifically in the nanosafety and nanotoxicology field. Together with some colleagues, maybe you know Eva Balsami-Jones from Birmingham and Fleming Cassie from Netherlands. We have been building the coordination team of the nanosafety cluster in Europe and created a document to somehow show the connection of the nano world with the nowadays advanced materials world. There is a quite nice publication around which goes from nanomaterials to advanced materials, and some key points there are, of course, that the advanced materials are designed to provide technological responses superior to those of their conventional counterparts, and also that there is a strong focus on the properties and that they have controlled and unique advanced behaviors. These come very often on the nanoscale. This way it's easy to just say, okay, advanced materials, of course, include the group of the nanomaterials, definitely. And some of them are smart, some of them are responsive, some of them are composites, porous materials, different kinds of. So this was one of those key parts that help to understand what we are talking about. In the same direction, there is the work towards how to filter out what should be included and what should be not included with the term advanced materials. The Working Party on Manufactured Nanomaterials of the OECD has created a working description on advanced materials, mainly towards supporting themselves to find a very clear way how and what should be included in terms of advanced materials. So they are rationally designed, they have new or enhanced properties, targeted or enhanced structural features, and the goal, the objective is to achieve specific improved functional performance. Now, what is the key connecting point also with the part I just mentioned before? One of the aims is to improve the safety and sustainability, and of course, to make it possible to have a regulatory coverage. In parallel, of course, it is important to identify knowledge gaps and to create recommendations for action, which means based on this working description, it was already possible the recent years to move forward in a certain direction. Similarly to what we have published in this document about from nanomaterials to advanced materials, there is a nice overview of those material categories which are considered as advanced materials. And you can see this list, which gives an overview and a kind of introduction, what is in this advanced materials field. And of course, there is some other things ongoing. Antonis mentioned in the introduction that I'm part of the ISO 229 plenum, so for the International Standardization Organization. And there we are working on a definition on advanced materials. It's not yet public domain, so I'm not allowed to show it, but it will come up definition, and there will be another discussion round in the ISOP group next week in Stockholm. Now, getting into the ecosystem, at least the group who is here in the web meeting has now a rough idea what is meant with the term ADMA. So we are now on the same page on that. The European Commission, you see here, Jürgen Tiete, the head of unit in the RTD Department of Prosperity. He was in a meeting in the BNN networking meeting in Vienna on early March and presented there his understanding, or the Commission's understanding, of the ecosystem. You see there this kind of a house created where we have the advanced materials R&I on the one hand, the fast track from lab to fab, the capital and financing, the production and use of advanced materials, but also the overall governance with the Technology Council for Advanced Materials. This structural thinking about our ecosystem should help us to find our way forward. And this is where I see the connection point. So my question now is, and this I want to further elaborate, can SSBD be seen as a cross-link of these 5 pillars? From my point of view, it's important to know where SSBD comes from and to have then a quite easier understanding on if it is a link or not between these different parts in the ecosystem. I break it down, and please don't take it as that this is the one and only part where the development comes from. But I would say it's one of the most important and most consequent parts where SSBD has been supported. On the one hand, in the European Technology Platform for Sustainable Chemistry, in the SUSCHEM, Antonis mentioned, I'm one of the national platform coordinators and part of the European platform in that way. On the other side, there's a strong part coming from the NSC, the Network on the Safe and Sustainable Chemicals and Materials here in Europe, formerly known as the Nanosafety Cluster. So the safety and the sustainability comes together. Some important milestones or things are mentioned here. You see the AMI 2030, the Advanced Materials Initiative. This was based on the Materials Manifesto, published 2022, and then consequently pushed forward. And nowadays, it majored towards a partnership which is named IM4EU, which is run by an association named IMI. In this Advanced Materials Initiative, on the one hand, SUSCHEM was one of the co-creators of it. On the other side, the NSC was one of the core team partners, bringing safe and sustainable by design into it to bring forward products, materials that are safer and more sustainable. A key role nowadays plays the IRIS project, which is also mentioned here in this part. It is a coordination support action project, and I will come back to this on a later slide to show where it elaborated towards now and what we can expect in the future to interact with. Okay, this is the side of the kind of initiatives and projects. And then on the right-hand side, you see on the one hand, the Advanced Materials for Industrial Leadership documentation, which was published by the European Commission. Across all this, the Safe and Sustainable by Design framework is a part, and it's included there. There are 14 elements that are shown by the Commission on their webpage, where they run forward to push towards more safe, more sustainable products, materials, and chemicals in Europe. Supportive from the funding side, on the one hand, should be the partnership IM4EU, and a new kid on the block is the InnoMatSyn project. It's again a coordination support action. I'm happy to coordinate this, which will feed into creating synergies between the different activities on regional, national, and European level in the field of advanced materials, and also, of course, focusing in a certain extent on SSBD. Good. Having set here the scene from the bigger picture, now where SSBD really comes from. And this is quite a nice story. On our side, at BNN, we started already during the first iterations of the so-called NanoRec project. And then based on this, where safe by design was the key element, afterwards the Sustainable Development Goals have been published by the United Nations. So we said, okay, why not putting SBD and this sustainability elements into one big box. So our first iterations of SSBD, of course, no one was speaking in 2016 about SSBD, so it was not yet existing, but we already implemented this approach at that time and published a paper on this towards a methodology on how to create a real-life relevant risk profile for a given nanomaterial, so very much focused on the nanomaterials as well, and also including already some elements which nowadays are included in the bigger picture in the so-called SSBD framework. Our goal in that was a kind of ideal situation that everything is made safe by design, also addressing, of course, the sustainability aspects, including here you can see also the money part, so the economy, including the environment, so these aspects, and also the society with measures around the public perception, but also ethical aspects. The key was that at the end it goes somehow to the market and that we gain a difference with what we have invented on the labs to bring something also to society. So this is one of the starting points. In this publication, we also showed this kind of safer nano innovations, first ideas, and that we need some specific steps how to move there. Because this is tackled also then in the SSBD framework discussions. I will not go into the deeper parts of this. But then, okay, besides the several FP7 and Horizon 2020 projects, which focused on safe by design, all of them compiled in the NSC. The NanoRec project, of course, made the one big clash on also creating the first regulatory testing environment. Nowadays, of course, PARC and all the big projects can harvest quite a lot of knowledge from what has been done in 2011 to 2014, 2015. Another milestone from my point of view, and it was also now recently presented in a publication of Peter Fandke, was the non-paper, which was created. Again, SASCHEM was involved to a certain extent. Maybe some of you know Vivi Filipussi, who is now at the Commission, and other players of the NSC have been involved to create this document, Safe by Design for Materials and Chemicals. Nowadays, with approximately 4,000 views and at least 2,000 downloads, it's one of the most attractive documents in the completely open published Zenodo repository. Stepping back to that, then the chemical strategy on sustainability came out, the Green Deal in 22, the SSBD recommendation, and as far as I know, there will be some first iterations on the SSBD revision to be published and presented during the EU INTEC conference early June by the Commission. So from my point of view now, it should be clear to everyone in the room where SSBD comes from. Now back to the ecosystem. Here is the overview, which should help you to find your way where we are at the moment with all these activities. On the one hand, in the advanced materials ecosystem, but also where SSBD comes in. And from this big picture, you see that I added, of course, I'm from Austria, so I added the Austrian community, where several different parts are connected. The lightweight materials, the metallurgy, the additive manufacturing, nanotechnologies, of course, also smart textiles. So very application-oriented parts are included there. On the one hand, on the regional level and the national community. This needs to be connected to the European level, which InnoMatSyn will be a crucial role in the future, but coming back to this later. And around the surroundings are well known, some funding programs tackling these topics, most of them already including SSBD nowadays. For example, the BioNanoNet calls have it more or less as a cross-sectoral part included. Also the lightweight materials activities, IMI as the association who is running the partnership now. There should come up an important project of common European interest, which will tackle circularity in advanced materials development. Of course, also the EITs are active there, and IRIS plays a crucial role. So in the next few slides, in this ecosystem, I want to highlight these three parts. So the NSC, the InnoMatSyn, and the IRIS. What is the NSC? It's the Network for Safety and Sustainability of Chemicals and Materials here in Europe. It has quite a long story behind. First time starting in 2009, implemented, then based on the action plan. Roadmaps have been created. I mentioned already the transfer from nano to advanced materials. And recently a roadmap was published and recommendations given to the Commission how to move forward. What is the path towards the development and utilization of advanced materials to make them safe and sustainable? It's quite a big community with a clear vision to support the development of the chemicals, that they are safe and sustainable, addressing the entire life cycle. Knowledge sharing is important, and the timely and proactive input for all regulatory needs is in the vision of the NSC. The mission is that this grows and supports and creates synergies. New scientific methods are established, and that a long-term collaboration that goes beyond the lifetime of EU-funded projects is established. With these key parts in mind, this is kind of the structural setting that on the one hand, there are groups of projects that are already meant to collaborate because they are funded in the same European funding course, and they are interacting in so-called working groups. I want to highlight one of them, and one of the chairs, Hernandez, is later on also a speaker in this webinar. So there is a specific working group on safe and sustainable by design, which also addresses innovation and regulation. Of course, there the key part is to move forward, to say, okay, there are methods, tools, and technologies for SSBD purposes out there. So you will find them there. There is an SSBD demonstration. Several case studies are ongoing in the projects. Normally, they are somehow disconnected because the projects have a certain kind of surrounding where they are active and are not meant to look outside the project. This working group is the place to interact and to find out, and this is, I think, one of the key parts, or also for the future, to create some kind of SSBD scenarios. This should support the implementation of SSBDs. On the one hand, for the small companies, SMEs, but also in industry. And finally, regulatory preparedness will support that all these activities and also the advanced materials, but all the inventions and chemicals and non-related materials, that they come at a certain time safe and sustainable to the market. This, in a nutshell, is the NSC community, which comprises 1,500 people at the moment. The next part is the InnoMatSyn. This tackles funding bodies on the one hand and initiatives. On the one hand, the funding is very fragmented here in Europe, and InnoMatSyn will gain synergies between the different kinds of funding. It will create this kind of European ecosystem to support the development and innovation in the field of advanced and innovative materials. but it also will look into this kind of technology leakage risks. Is there something that maybe is used not in the good way, but maybe in another way? And this will be mapped there as well. Finally, this part of interaction should lead to a very, very effective and good tackling and integrating into future funding, on the one hand, the topics around the advanced innovative materials, but it will also include sustainability and safety aspects. Finally, coming to the IRIS project, which is the International SSBD network to accelerate the transition to SSBD materials, products, and processes. This is in the final days of its project runtime and has created quite a nice option to continue the interaction. The so-called spaces, which there is a digital platform created by the IRIS project in which you find different spaces in which you can find relevant information, either in general about SSBD or tailored to specific application areas. Also, the NSC has a specific community space there. So also the projects that are running are somehow addressed in this ecosystem. If you're interested to learn more about the IRIS ecosystem, of course, you're more than welcome to consult the web page, but also to join this community. Finally, to come to more as a kind of conclusion of my talk, I see that SSBD is definitely a cross-link in the ecosystem. Here on this slide, you see a recently published implementation document. We have done some work on implementing SSBD, at least to start somewhere, maybe with a small piece, but at the end, to implement it and to learn during the implementation where we see maybe issues coming up or where we see the benefits. We did this with the redox active molecules for the redox flow battery, so in an energy storage application, which has the potential to be entering the market quite soon. So SSBD is not so artificial anymore. We just need to find our way how we deal with it. And I think using this ecosystem we have around us, specifically this advanced materials ecosystem, will support our efforts to implement SSBD and to make a difference in the future. With this, I want to give you a short wrap up. On the one hand, become part of the ecosystem. If you are sitting in front of your screen and your smartphone is at your hand, you have the chance now to immediately scan the QR code. You have 3 up there. Each one you can scan. ATMA would be our Austrian community on advanced materials. NSC will be the community of NSC, and InnoMatSyn will be also, all the 3 of them are on the LinkedIn, so that you can follow without any additional barrier what is going on there. I'm sure the slides will be shared afterwards with all of you, so you will then be able to click on this link to become a member of the IRIS SSBD community and to be benefiting from the information that is available in these spaces. So my claim at the end, start the implementation of SSBD at the earliest stage of development to increase the safety and sustainability of the things you are doing. In case you need a partner for the implementation, you can come back to BNN, of course. And I think that the collaboration is the key to shape the future towards a safe and more sustainable world. With this, I'm at the end of my talk. Just two small advertisements. This is BNN, as mentioned already. We have quite a nice network on the one hand, but also our support parts where we can support you maybe for your project, for your work with SSBD implementation, regulatory support, valorization support, things like that, but also with networking. And I'm so happy to not do it alone. Here, a recent picture within the background, the sightseeing landscape in Vienna with the Stephans Tower from the dome. This is my team. I'm super happy about them. They're doing a great job, and I acknowledge the projects listed here. And super happy. Thank you for your attention. I will give back the word to Antonis.
Thank you very much, Andreas. Thank you very much for the presentation. I would like, first of all, also to remind our participants that they can put questions, in the chat. And again, concerning the presentation of Andreas, I think you have already, thank you very much again. I mean, you have already provided an excellent basis about the wider scope and perspective, behind SSBD, and which is another reflection of the dynamic approach towards sustainability. I like this one. You essentially started as an SBD, correct? And then you pick up this additional letter on the road. I have a simple question for you as we probably wait for some comments or some questions from the participants. Andreas, at this stage, are we in a position to say that this, say, in your community, nanomaterial supply chain is better on terms of SSBD than another supply chain? If you compare supply chains, can you say that one on SSBD terms is better or worse? Can we say that?
Thank you for the question, Antonis. I would say the supply chains are a very important kind of how to apply SSBD, because the one part depends on the next one, which means you have several stages where you can iterate on this. This brings me back to the starting point, as you also reflected on SBD. SBD was based on a stage gate process. Karl Höhner, Tom van Duynbroek, and we were discussing, okay, how we can make clear decision support along this kind of supply chain, if you like, or development chain, or innovation chain, or value chain, however you want to name it. But you need some kind of decision making points. And I would say SSBD has the power to be the tool for enabling a very nice and consequent decision support along a supply chain, value chain, and so on. However, it will need also, and I'm quite sure Spyros will tackle this, it will need thresholds, it will need trade-offs, it will need a set of methodologies that need to apply at the specific steps. These things are well under development, but they will be the enablers for the implementation in the long run. And on the other side, for these supply chains, I think the digital product bus will play a crucial role in the future, where you then feed into some relevant data. If on this supply chain it is possible to screen where does the material come from, how was it processed, is it safe, is it sustainable? So this combination, I think, in answer to your question, this is exactly the strength of the SSBD concept if it is applied consequently.
Okay. Thank you very much again. I can see no questions, so we will be waiting for Spyros to fill in the gaps for the answer, in his presentation. And it's pleasure now to introduce our next speaker, Sophie Wilmet. Sophie, please. Okay, show yourself. Sophie is an innovation manager for CEFIC. She has joined the Research and Innovation Department of the European chemical industry in 2007. And she's currently innovation manager in charge of enabling technologies. She's responsible for activities related to CO2 valorization. She's a member of the partnership board of the PPP Spire, and is also actively involved in the European Technology Platform for Sustainable Chemistry, SOSCHEM, as we know. She graduated as a chemical engineer as well, so we have here a bias for chemical engineering today. in France, and she holds a PhD in chemistry. So, Sophie, please welcome. Please feel free to share your presentation.
Yes, thank you for...
And before you start, another reminder for the audience, please put questions in the chat and we will be dealing with them after the presentation. So, Sophie, sorry for the interruption. Please go ahead.
Yeah.
You need to share the presentation.
Yes, can you see it?
It's coming, I guess. No? Yeah, it's coming. Thank you.
Yes. Okay, so good morning, everybody. So indeed, my name is Sophie Wilmet. I'm working at CEFIC, which is the European Chemical Industry Council, and in the innovation department, as mentioned. And I will bring here a kind of industry dimension to the topic of safe and sustainable by design. And I will focus my presentation of the document that have been developed by CEFIC in the past years, taking into account, the development on SSBD. So we had previously the presentation from BNN, and just to put things into perspective. So basically, the concept of safe and sustainable by design came under the famous Green Deal of the previous Commission, which included a zero pollution dimension. And as part of it, there was a communication on the chemical strategy for sustainability. And that part included an innovation dimension, and the innovation dimension was about safe and sustainable by design. So this is where the development started, both from the Commission side, but also industry started to look at it. That's how you see the. Can you see this? As you can see, we had the first publication in October 2021. So basically 1 year after the publication of the Commission on the Chemical Strategy for Sustainability, and a second one in April 2022, and talking about the transformative power of safe and sustainable by design. And then we came with a more detailed guidance document last year in March. And this is really about, how to guide innovation, how to ensure that safe and sustainable by design can be implemented, taking into account the innovation process in the industry. So this is really about guidance, really for, research and innovation. First, looking at the dimension that are taken into account. So as part of safe and sustainable by design, so you have the safety aspect, obviously, with chemical toxicity, for example, product safety, health and safety. And then you have the 3 dimension of sustainability. So starting with environment, we have the climate dimension, how to reduce the climate impact. And so that can be through different options. Using different type of feedstock, using different type of energy sources. And then also improved circularity is a big dimension for the environmental dimension. And of course, protect, preserve, and restore ecosystem. So this take into account pollution, but also, water, soil, and to reduce resource use, for example. Then you have the societal dimension, and that's where, of course, it's very important to take into account the value chain dimension. So this is not about consumer directly, but also this value chain to the industry part, from chemicals to end product. Employment and workers is also a very important dimension, but also local communities and, of course, consumers. And at work, then well-being, and in companies, but also with community engagement, for example. Then we have the economic dimension of sustainability, with again, this value chain collaboration, so the collaboration with the supply chain and downstream value chain, transparency of information with regard to products and product performance is, of course, a major, driver for development of new product. And of course, the economic and technical aspects, and that include for, companies obviously profitability, but you take it at a global, at level, more the sovereignty also, and it's also about the life cycle. Taking into account this 4 dimension of the assessment, if we move to the concept of stage gate process and how innovation is developed in the industry. So if we look at the innovation process, you start with the ideation phase. So this is early research. Then you will go to the feasibility study. Then you have the lab phase, followed by the scale-up, and then only you will have the launch and the production. So the first phase, with ideation, is obviously driven by, for example, performance of products, business opportunity, and the second phase is really about innovation development, and then you will have innovation. So something very important is that in the industry, you always have a kind of stage gate process between the different phases of scale up, and then before you go to production. And one thing which is very important in the context of SSBD is that to evaluate the 4 dimensions I mentioned before, safety plus the 3 environmental dimension, you need data. And that's something very essential when talking about SSBD, is that it's important to take into consideration that the access to data is very different where you are at low technology readiness level, at the really research phase, ideation, creation, and it's very different when you have very high TRL, where you have much more quantitative data. But at the early phase, you may have to work with a very lean approach and more qualitative data. So the approach proposed in the guidance that has been developed take into account what I've proposed and presented before. So the 4 dimensions of sustainability, taking into account this innovation process with the different steps, but then also look at, okay, how to proceed in the different type of activities. And then later on I will show how those 2 dimensions of the guidance come together. So we can start with the activity to define the driver for innovation. And so what are the key dimensions of development? So this basically often about performance and functionality. And then you have this activity 2, which is about looking at what are the different dimensions for improvements, for assessment and for improvement. And that's where you recognize then the kind of 4 dimensions for safety and sustainability. So safety on one side and a 3 dimension of sustainability. Then you will have to look at what should be the design principle for your product or your process. And that's where also you have here, but if it's about the product, for example, it's important to take into account the design phase, of course, in the use phase, that's what drives the performance, but also taking into account the whole cycle starting from the use of raw materials, the production, the use phase, the end of life, or recycling. Then you will have need for data, and that's where, toolbox for assessment would be important. So activity 1 to 3 are really interdependent. And if you put now in perspective, as I mentioned also, the stage gate approach that is implemented in companies for the innovation process, this is a kind of overview on how it look like. So basically, in the initial phase of research, with from ideation creation to feasibility study, that's where you will look at, performance, functionality needs, and take into account, for example, stakeholder and corporate requirements. Of course, take into account the intended use. But also look at what are the minimum requirements, so you have a kind of list of what is needed to move to the next step, and starting the feasibility study. For activity 2, then you have the identification of the scope for assessment, and that's where you have to look at what are the relevant hazards, what again is the intended use, and linked it to exposure potential assessment, and relevant sustainability dimension. So remember the 3 dimension of sustainability, with the economic dimension, the environmental dimension, and so for this option, going too fast. So then you can look into more details on the design principle for identified assessment of the dimension. And so this will then be something that will need to be adjusted while, innovation is in progress. So after the selection of the design principle, you have the activity 4, which is about how to perform comparative assessment. And that's where you need tools and data. So for the tools, that's very important to have access to a relevant assessment tool to assess all the dimensions that you have identified for the assessment. And also checking, for stakeholders and also corporate requirements along the value chain. That's where that is done, really from the feasibility study to the scale-up, something that is to be reassessed at each development stage. Then we move to activity 5, which is about trade-off, actually. And because usually when you develop, new product, for example, you, as I mentioned, you start it obviously with some, for example, objective for performance improvement, and you try to take into account all the other elements that you want to incorporate in safe and sustainable by design approach. And very often you will, improve many elements, maybe not all of them. So you have to, decide for trade-off. And that's really something that is about, choice. Then, of course, again, taking into account the availability of data. This decision process is different when you're still in the early phase of the feasibility study. It's very different when you had at the scale-up phase, for example, when you have much more data to really select the solutions. Then about the design principles, here you see for the environmental dimension that the list proposed for the design principles. So you have obviously the climate dimension. Then you can, separate between climate change, adaptation, mitigation, You can incorporate there also the energy dimension in terms of what type of energy sources, energy carriers are used in the process. Resource and waste is another major dimension with what are the type of resource used as feedstock, to what are all type of resources inflows, but also what are the outflows related to the product, but also the process. And then you have to look at waste, and that's also where we have a link to the, very first box we have on this infographic with the issue that are related to recycling conditions, and so to take that into account. Then you can also look at the biodiversity and ecosystem impacts with direct impact, but also impact on the different elements such as state of species. You can also the condition of ecosystem, or look at dependencies on ecosystem services. Emission into air, water, and soil are a major element as well. So that could also be divided into subcategories as you have there. And protection of water and marine resources is part of the proposed framework. So this is not necessarily an exhaustive list. This is just as guidance for the design principles. And you can also consider, other, documents. Here the EPR, which is the extended producer responsibility, is mentioned as other source of document that can be used to analyze and also evaluate these different activities. So for what is important to keep into mind is also to always take into account, so even if it's driven by, the innovation is driven by the design principle for a product, to really take into account the production phase, as well as the use phase and the end of life. So these are very important principles along the guidance. These are very more detailed examples just for the activity 4, which again illustrate, as mentioned before, the dependence on data availability. And that's how you see at on this graphic the level of predictivity that obviously increase when you move, along the development of your project. So this is very detailed. I will not go into details here. You can see, for example, in that case, where you have the hazard assessment and examples of hazard endpoints, and then looking at different approaches and tools that can be used either in the screening phase, and you have here, for example, NAMs, which are new approach methodologies, but also the regulatory testing, and important as always, what are the available data you can really rely on. So one example here is about, for example, if you take again the stage gate process. So you start from the ideation phase, and so obviously going to successive phases and ending with the launch of the production. And so we have to clearly make the distinction between what is really new, called new chemistry here, but it's really totally disruptive, let's say, innovation, versus incremental innovation, where for incremental innovation, in general, you have already more data than if you start really with a totally disruptive approach. That's why here, overall, what you can see that we say that when it's incremental innovation, you will have to work with this more qualitative evaluation and screening type of RCA up to the feasibility study. But then as soon as you are in lab phase, you will have access to quantitative data. While for, really what we call new products or chemistry, then you will have to, do the development with relying more on qualitative and screening type of LCA, at least up to lab phase. This is just, to illustrate the challenges and take into account that SSBD in principle is very data intensive, but it's not possible to always have access to all this data. And then, for example, we have this, we put this list of examples for impact categories, but this is just as an example, so you can imagine the number of data that have to be looked at. We also mentioned here some type of standards with regard to this example. So this is another overview just to be a bit more details about indeed making the differentiation between what I call more disruptive innovation versus incremental. So this is an example that we have in the document that I mentioned at the beginning of the presentation. So it fits about this really disruptive, as I mentioned. You will have to look at, for example, the hazard exposure and the LC. It's more identification of potential concern and suggest a check for element to be looked at in the early phase, and also identification, what could be the potential issues. And well, then you can start to exclude some elements when you're in the lab phase and the scale up, and you can do the kind of hotspot analysis, for example, for exposure, and identify the improvement potential for different candidates, for example, from the lab research, and comparisons between them, but also with existing projects, for example. And then you will have the full data set only when you have reached the scale-up phase. That's really when you will have all elements to do a proper, qualitative and quantitative assessment at that stage. For the more incremental innovation, that's what you have on the right hand on the slide here. And that's where you see the process is basically very similar, but you will start to have more quantitative data at an earlier stage. And it is important that because you always have these criteria at each element of the gauge process, and that's where you see that it differs from new innovation to incremental innovation. For example, for the feasibility study, for incremental innovation, you can already have judgment based on existing data. This is where at the new to the world innovation, you would have only definition of requirement. So that's a major difference that has to be taken into account when we're talking about SSBD. And same goes, and when you move on, it's always this very different situation when you have in disruptive innovation versus incremental innovation up to the gate, which is about the scale up and the launch, and where and then you have the similar situation. And this is something we need to insist on, because the concept of safe by design, and supporting innovation for more sustainable and safer products is really that it is understood that not all projects can follow exactly the same rules to a certain extent, because and the same framework, and because they have to adapt to data availability. Then about trade-off decision, I mentioned it earlier in the presentation. This is about how to support decision making, because it's basically this as part of this overarching activity that during this process, I mentioned this activity 1, 2, 3 that are intellect, and then activity 4, there will be a need for trade-off decision. And this is important to have to take into account that for that, first, they should never be trade-off on safety as a principle. This is what is proposed. And it's very important to always take into account this life cycle perspective when it's about trade-off decision. So that's why we need to have as much as possible, this decision to be supported by information that can be verified. And of course, this is something that is always inherent to specific projects, so difficult to come in more details on that part. So the guidance document from CEFIC was published in May 2024. So after the publication of the recommendation and the framework developed by the JRC. So we had some feedback from companies, and one of the major points was that it was considered that this guidance and the principle as they were presented there in the guidance are pragmatically applicable in the industry. The approach seems to be implementable, easier to implement than the initial JRC framework. And the companies have started to test it, to compare it to the JRC framework. The major point is what I started with in my presentation is the fact that instead of developing a separate framework, it takes into account the innovation process as it is developed in companies. So it's more about how to integrate the principle of SSBD and a proper assessment, depending, of course, on the TRL level, how to integrate the SSBD principle in the existing innovation process. Whether they're developing a parallel system that is disconnected from the innovation process and that is extremely resource demanding and also data demanding, and again, upon that, that was highlighted in this presentation, that data are not always available. So in order to really support innovation, we have to take this into account when developing SSBD. So the concept is also connected to some developments. For example, what is done at WBCSD level, so the World Business Council for Sustainable Development. They have this assessment, for through sustainability development. So just making the link between SSBD principle and what already exists, and is very important. And of course, it's the idea is to support innovation, and that was the intention in the Commission communication. So the idea is to see how to have a pragmatic approach and something that can be actually implemented in the industry to support innovation. So, but next step, yeah, we, as an industry, I mean, we support the objective of safe and sustainable by design, with the objective to develop safer, more sustainable products. We say for sustainable product need to stay, I mean, manageable, workable in the industry. So it's important to have something that is, in particular, early phase, obviously lean and practical, and also to really integrate these in the existing innovation process. It should not be too resource intensive. It should fit in the basically resources of an innovation project. It's also very important to have this this flexible, I mean, methods tool, having access to tools and database that have to be developed for, I mean, new activities. And then, of course, funding can help to support support the industry to test, to support the academic and RTOs to develop, I mean, new, I mean, the tools and or develop, I mean, existing one. It's also from an industry perspective, a very important point, of course, make sure that this can be implemented while, I mean, CBI is respected. So make sure that we have secure and easy data sharing while, I mean, having protection on the intellectual property. Global competitiveness is a major, I mean, challenge for the European industry. So this is important also to have to take this into account and avoid that that we have isolated solutions developed in Europe aligned with global standards where it makes sense, and also make sure that we can combine SSBD with established portfolio analysis methods. I mentioned WPS-CSD before, but there are others. And
yes. Wrap it up since we are running out of time, and we have some questions also that may be interesting.
Yeah, it's my last slide, okay. So this is fine.
That's okay. Again, let me remind our participants that they can put questions in the chat. Presentation of Sophie, mentioned some important directions that we have not seen in LCA, like innovation, like circularity, like the advanced role of ex-ante. Yeah. And again, that's another reflection of the dynamic approach towards sustainability. We have two questions, Sophie. One, I come from the last one since it relates to your last part of the discussion. Data is key to the application of SSBD, but this data may not be available. So how we can tackle with the issue of data when data are not available?
Yeah, so that's why, I mean, I'm highlighting this difference between, I mean, new and incremental innovation. So disruptive versus incremental, because indeed, when it's about incremental, it's easy to do, I mean, comparative assessment on some aspects. While when it's new, then it's much more difficult. So the fact is that that's why you have this qualitative assessment or qualitative comparison. I mean, later in the innovation process when it's disruptive innovation, because you have this lack of data. For incremental, you have the existing product, and then you can compare and assess.
For generative AI, because you can proxy for things. If you are not having the data for this particular thing, you can use AI to find something nearby, or probably use AI to give you an estimate of the thing that is missing. Yeah. We have another question, Sophie. It's about PEF, the product environmental footprint, and the question from Antonio is about PEF, and this PEF is being developed in the EU to evaluate the environmental footprint of products and how this fits into SSBD. I mean,
So-
what PEF, the product and environmental.
Yes. So yeah, I know there is work. I mean, this is I have some colleague dealing directly with PEF, and they would be better placed to answer to that question. But I can still answer. I mean, the product environmental footprint is indeed, I mean, not a revision for many of them, but the point here is safe and sustainable by design is really proposed as a guidance for innovation. So while the product environmental footprint is really about how to evaluate the environmental footprint of the product that is on the market. So I think that I'm not aware of direct connection at this stage, but I could check with my colleagues. We haven't discussed that point, but I think it's really important to take into account SSBD is there to guide innovation, so to really guide the improvement in different dimensions, taking into account all dimensions proposed, while PEF is really about assessment of the existing product that is on the market.
Thank you, Sophie. I mean, I'm afraid we have to stop it here, and thank you again for this inclusive, presentation of yourself, of the work that you have done at CEFIC so far. And let me quickly, since we are done with time, to our next speaker, Spyros Karakitsios from the Aristotle University of Thessaloniki. Spyros, please welcome. Please share the presentation. Meanwhile, let me get the chance to present Spyros. He's a biology scientist. Graduated with a background on physics, and an MSc in chemical, environmental, and computational technology, and a further PhD in biological applications and technology. He has spent time at JRC. And he, since 2011, he's working at the Laboratory for Environmental Engineering of the Department of Technology at the Chemical Engineering School of the Aristotle University. And Spyros, we will touch on one other major project, PARC, that aims to develop next generation chemical risk assessment, so computational kind of tools, related to the questions that we received last. This is a project that relates also to the European Green Deal's zero pollution ambition. And again, it relates to data, knowledge, and methods and tools, that can be used. And this PARC is a huge project that involves, about 200 institutions, and 28 countries. Probably you haven't missed any of them, Spyros, in this kind of project. Yeah, you have them all. And so you have a lot of, material. So apologies, we have to start, late in your case, so again, try to get back to the time as fast as possible. Thank you very much for.
Yes, I will try to do my best to be concise and to not spend too much time on details. Thank you very much for the very kind invitation and for the introduction. Let me share my screen. Okay, so I'm going to give you a brief introduction to the work that we're doing in PARC with relation to the development of the SSBD toolbox and the link with the next generation risk assessment methodologies that are extensively developed in PARC. Professor Kokossis has already made a very nice introduction about PARC. As most of you know, it's a very large initiative related to chemical risk assessment, and with a particular focus on new generation risk assessment methodologies. It involves a large number of countries, and it has a significant budget that allows a lot of things to move forward, especially in relation to the duration of the project, which is 7 years. So we hope that we'll have significant outcomes by the end of 2029 in this direction. And of course, one of the significant parts of the work that is going to support the chemical strategies for sustainability is the work that's carried out in relation to the SSBD. With relation to the SSBD, one of the major mandates that we have within PARC is to develop the so-called PARC SSBD toolbox. So what we have tried to do here is actually to support both the SSBD framework, also in the initial form, but also the evolving SSBD framework, because we know that there are a lot of discussions on how we can make this framework more applicable. And at the same state, at the same point, we try also to facilitate the innovation stage approach. So we try to bring together with these two words by providing the necessary tools to do this. And we try to cover both the aspects that are related to chemical risk assessment, that are described here, and also the ones that are related to sustainability aspects. Now, with regard to the broader vision of the SSBD toolbox, obviously this is not only a connection of tools for SSBD, but is actually an integration and innovation tool for both regulators and innovators, and aims to bring together data, methods, and tools that they can support the SSBD assessment. And we try to make this functional through model pipelines that you will see in the next year that will be developed in different ways. Also, already developed and fixed pipelines, but also automatically developed pipelines based on the request of the users. Obviously, we need to make this compliant with the FAIR principles, also in terms of the models that are used, but also in terms of the data that will be used for the different kinds of assessment. And obviously, we want to make this suitable for both newly developed, but also for existing substances. So we will support also the redesign process and also the comparative assessment of potential substitution. Now, if we want to go a little bit more to detail, in terms of functionalities, this will be a leading collection of tools for SSBD, and it will be an inclusive platform that provides all the relevant data, methods, and tools for implementing the SSBD framework, which means that this will be an interactive and open platform. So not only tools that are developed within PARC will be included, but also we invite people outside PARC that they have developed tools, different kinds of models or more integrative toolboxes, to include them within the toolbox and to act as an overall umbrella in this direction. As I said before, we'll have functional links and workflows through the different pipelines, and we'll have 3 modules: manual, hybrid, and automatic. And of course, a critical component of the overall assessment is the decision support system that we are developing in order to be able to integrate all the different functionalities. And this will be supported by multi-criteria decision methodology. In terms of applicability, we say that this will be suitable for both newly developed and existing substances, and will have, at the moment, has a focus on chemicals. And in the next years, we will want to extend this focus also in materials in order to be able to cover the different sectors of chemical industry and the different innovation scopes. In terms of audience, it presents an integrative innovation system for different types of stakeholders. So although the particular focus is on industrial stakeholders and SMEs, obviously it can be used for researchers, and it will provide results that can be interpreted by regulators. And it has a logic of mutual learning and incorporation of key findings and methods from other SSBD projects. In terms of data, we want to link this with different kinds of databases for safety and sustainability, so we can facilitate the assessment of the different users, because we understand that there is one of the major bottlenecks for the assessment of the SSBD is not only the existence of tools and how we can link the different tools in order to address the different scenarios that we would like to study, but also to how we can identify the data, how we can fill data gaps. So in this aspect, the use of AI, the continuously increasing use and availability of tools for AI will be a significant tool for data gap filling, of course, with respect to the FAIR principles and also the confidentiality aspects that have to be taken into account, because we have to do with a tool that is main use will be done by industry. In order to guide the users for the development of the toolbox, we are developing the so-called SSBD wizard, which is a user guidance through the whole assessment process, considering the different innovation stages. And it will describe all the different elements within the toolbox, how they should be connected, and how it will be the information flow that the users should follow. So as I said before, we aim to bring together the different tools and methods to support the sustainability aspects and actually to forge links between the different tools. There are technical ways that we are doing this. We are working closely with our IT experts in order to ensure the functional link between the models. We understand that this is not feasible for all the models because we don't have the source code, or not most of the models, they don't have APIs. We're in contact with the different kind of model developers and see how we can extend this functional link. So we move from a library of tools to a different development of different kind of workflows. As already mentioned, we will develop a module that will allow the user to have different kind of pipelines. So for the very experienced user who can have a manual pipeline, if a user knows what tools he needs to use for his assessment, or eventually he feels more familiar with, we'll have an automatic mode for the less experienced user. So the wizard itself will select and will propose models, and the pipeline to assess the workflow will develop automatically. And of course, we'll have the hybrid mode that will allow us to change some individual components of the automatic mode. Obviously, this will need to retrieve data from different databases. A very important part is the blockchain technologies for the use of proprietary data, because we understand that this is very, very important for industrial users. And of course, at the different stages and steps of the assessment, the wizard will be there to support. We have done several steps from the moment that PARC has been initiated on May 2022 to end up with the version 0.1 the previous April. But actually the aim is to go to the alpha version, as we call it, by the end of May. So we want to advance further the existing functionalities and to incorporate several additional tools and functionalities. You will have the opportunity to see the alpha version in a workshop that will be planned by most probably the beginning of July. I think that by next week you will receive more information in this aspect. We'll be very happy to have you in this workshop so we can present you the overall functionalities of the alpha version of the toolbox. Of course, this is an ongoing process. It's something that's currently under development. We have a lot of more years to continue to work in PARC, but we want to have this alpha version at this stage so we can receive feedback and to make this in a module of, let's say, in a mode of concurrent engineering. So we receive feedback from the different users and stakeholders, and we continuously evolve the concept and the tools and the functionalities that are included in the toolbox. This is one of the major exercises that we have done up to now, which is actually to align existing tools for safety and sustainability, how they fit within the SSBD framework steps, but also how well they can support the stage gate innovation approach. So this is one of the major components of the SSBD toolbox wizard. And based on the data availability on the different innovation stages, we guide the user what kind of tools they can use and of course where they can find the data. This is the webpage link of the PARC SSBD toolbox. So there you can find the toolbox, you can register. Of course, we are advancing this. What you will find at the moment is the version 0.1, but by the end of May, mid-June, we will have the updated alpha version that we will present in the dedicated workshop in the beginning of July. This is what you see if you register in the toolbox and you start to open the page. Of course, we want to move forward to a decision tree kind of wizard, which is currently developing. This is not the case at the moment, but this is where we would like to end within the next couple of years. Now let's try to say a little bit more things about the new generation risk assessment and how this can be connected to the toolbox and how they are already implemented and where we want to end up. First of all, let's try to clarify some things related to the terminology, new generation risk assessment and NAMS. Practically, NGRA is a framework or strategy for chemical risk assessment that is exposure-based, which is particularly important. It's hypothesis-driven and is built around the use of NAMS, the new approach methodologies. It aims to be human relevant, efficient, and aligned with ethical principles. NAMS in this direction are the building blocks, and NGRA is the architectural design that organizes and applies how these blocks are going to be used to evaluate chemical safety. So in practice, NGRA uses NAMS to predict hazard via in vitro bioactivity and mechanistic models and tries to organize them through adverse outcome pathways. So NGRA is based both on exposure assessment and pathway-based approaches. So in these terms, it provides additional insights in chemical risk assessment that we might not capture with the very traditional approaches. On the other hand, it takes into account human exposure, so it provides a more realistic assessment of risk. In this direction, exposure assessment is very important and is implemented through computational models. So it's important here to link external exposure very well with internal dosimetry, because most of the new approach methodologies that are in vitro based, they require to have the proper internal dosimetry of the environmentally relevant external doses. And the way to go backwards and to link this is the EVV, in vitro to in vivo extrapolation. And in this way, it's able to support decisions under uncertainty with integrated approaches by using NIATA. So NAMS are essential enablers for NGRA because without NAMS, NGRA cannot function. And it's actually the NAMS that will provide the data, the models, and insights that the NGRA uses. On the other hand, NGRA defines how and when NAMS should be used and maximize their reliability and relevance. And this is particularly important for SSBD. So NAMS practically is an umbrella term that is used to describe the new methods that are non-animal based for testing and assessing chemicals, material, and products safety. And some key components of the new approach methodology are the so-called in silico approaches, which are computational models, for example, QSAs that allow to make some predictions about toxicity, machine learning and strategies for as predictive tools to identify the hazard metrics that can be used for risk assessment without the use of animals. We have the in vitro methods that are cell-based, tissue on a chip, which are continuously evolving these kind of methodologies in relation to the macrophysiological system, for example, mini brains and other laboratory techniques that are human or animal cells and tissues, but not living animals. We expect a lot of things to come within the next years from the omics technologies, accounted for genomics, transcriptomics, proteomics, and metabolomics, and especially metabolomics because they are closer to the clinical phenotypes, so they can provide very good information, but most of the information and the better mechanistic understanding of this biological effect can be delivered if we map down all the different kinds of omics with specific bioinformatic tools. Additional methods are the ex vivo techniques, which are practically using tissues or organs taken from organisms, and they are maintained in laboratory environment. And of course, high throughput and high content screening, which are automated rapid test platforms that can screen hundreds and thousands of chemicals for specific endpoints or biomarker of toxicity. In this sense, colleagues from USA with the ToxCast 21, they are pretty advanced. There are limitations with these methodologies, for example, systemic toxicity, but still they can provide a very good idea and some additional level of information beyond users, and these are particularly important for the early stages of innovation. So how we can better use this in the SSBD context? it helps to map out early stage testing needs. And why this matters for SSBD? Because this can help us identify at a very early stage some red flags. So we can modify molecular structure or production process before we move to large-scale manufacturing. So in this case, we can cut down on waste, resource abuse, and time to market. So obviously, this can facilitate the innovation process. They can be used as screening tools in the design phase by incorporating high-throughput NAMs and including the different technologies that we described in the previous slide. At the very early stage of development, we can avoid unnecessary costs of redesign later. So let's think of several chemicals that have been controversial the last decades. Obviously, these tools, they have not been available the previous decades. And if they were available, maybe some of these controversial chemicals, they were not at the moment at the market because the respective risk could be identified at an early stage. So again, this is a tool that can support all the innovation process, can accelerate the design of safer chemicals and provide some competitive advantage to the European chemical industry. Of course, it helps us to identify and to prioritize endpoints, to focus on key toxicity endpoints and other hazards that are relevant to the studies. For example, endocrine disruption, endotoxicity, depending on the type of substance that we want to develop. And we know most of these chemical structures, what are the potential hazard considerations that we need to take into account. And of course, a very pragmatic way to move forward in this direction is to work on running case studies that we know that there is some particular need for substitution. Obviously, we need to use tiered approach. So we need to match the tiered approach that is proposed for the gradual use of more costly NAMs with the innovation stage approach. This is very, very important. But as I said, if we structure this in a proper way, then we can make this an advantage, not a complexity. We need to integrate this into the life cycle perspective. So we need to go beyond toxicity because SSBD is broader than hazard alone. And we need to see how we can integrate this assessment within the overall life cycle assessment. And this means in practice that we need to combine this with LCA tools. Okay, so this is particularly important also to what you mentioned before about the trade-offs, because a substance that might be safe for human it might require energy-intensive or non-renewable resources. So it might not meet sustainability criteria, and by coupling at an early stage the hazard data from NAMs with LCA outputs, you can have a more holistic view from a very early stage of innovation. Of course, it's a good opportunity to leverage data sharing platforms and framework, so we can increase the international collaboration in this direction and to use input that we can have from NGRA, from different platforms, as the one that I mentioned before, for example, Kokkosis 21, with the needs to support the early innovation assessment within the SSBD framework. And we need to keep in mind that actually NGRA has a very good alignment with the SSBD principle because it is in line with the proactive safety because it allows the assessment of potential risks at a very early stage. It provides the methods for making the integration with the sustainability aspects and reducing the animal testing. It has a very strong mechanistic and predictive power, especially if we are able to integrate functionally all the different tools that are extensively developing now in the NGRA with a focus on the adverse outcome pathways that allows us to organize the different aspects of toxicological information, the different kind of assays from ToxCast, omics data, accuracy, and of course PPK models that provide the link between external exposure and internal dosimetry. And of course, the holistic exposure understanding by integrating different modules of exposure assessment, like exposure construction from human by monitoring data, aggregate exposure modeling for accounting for the different pathways and routes of exposure that can be related to the scenarios of use of the specific chemicals, and of course, life exposure scenarios that account for mixtures. So tool integration pathways within the SSBD toolbox are these ones. We start from in silico tools. We'll describe the in vitro assays that have to be used in the different innovation stages, mainly stage 2 and 3. How we can use the AOPs that are informed by bioactivity data in order to support the decision support modules, PPK and VV models for the extrapolation of doses, and of course, high throughput exposure models. So practically, we'll need to move to a logic of IATA in this direction, collaboration with different other work packages within PARC that they focus in these aspects is important. This is a summary of some of the tools related to NAMs that we want to include in the toolbox, also within the alpha version that we're going to release on May. And just to close my presentation, if we want to highlight the strategic opportunities and the added value of NGRA elements to be integrated in the PARC SSBD toolbox, obviously the NGRA can effectively support the SSBD tiered approach that accounts for the innovation stages, and it can support effectively the stages 0 to 3, which are particularly important in order to accelerate the development of new substances. So in this sense, it can support the innovation and also to be in line with the needs of Green Deal and the Zero Pollution Action Plan. And at the same time, it brings together science and policy and translate complex NGRA methods, omics data, exposomics data into regulatory usable outputs that can effectively support the SSBD process and also the innovation efforts that are necessary in order to maintain the EU competitiveness. Thank you.
Thank you very much. Thank you very much, Spyros. What to say? I asked you to speed up, and your speed came up to be meteoric, assisting us to explore possibly with some other questions. Thank you so much. I see no questions, so let me just warm up a little bit. I'm also prepared to cut down on my conclusion, time, to save time. How to say? I mean, you are dealing with lots of data, yeah? And we have seen semantics, you mentioned AI, and I think you also mentioned, proxy models for prediction, am I right, or regression?
Yes, yes.
My question is, what are the AI and machine learning tools that you use mostly, other than that, for prediction and regression? I mean, LLMs, are you exploring LLMs or GNNs or other type of classification models, as part of this work?
Yes, this kind of models are extensively used in the sense of bioinformatics because there we have to deal with big data. So in order to be able to map down the different kind of omics data into toxicity pathways, obviously we need to use this kind of models. Also, we want to, in the next couple of years, we would like to include in the wizard a more, let's say, interactive form with the user. So obviously, we will like to use a natural language processing model so the user can interact more lively with the wizard. And that decision tree that has to be developed to, let's say, to be formed based on the questions and answers that the user will provide, something similar to the ChatGPT.
But SSBD is not only bioinformatics, so you have...
No, it includes also exposure assessment. It includes different kinds of models. For example, in exposure assessment, we can use this kind of models in different kinds of predictions. For example, I have used machine learning models for exposure assessment 18 years ago in my PhD for assessing exposure to benzene from different kinds of environmental settings based on the parameters. So we will see to what extent we can replace some mechanistic models, some deterministic models with AI tools. But this depends on the data. Obviously, QSAR, in QSAR we have a strong component of AI, so we can move from typical regression models, but to the ones that are based on AI. And I guess that also maybe in sustainability, but there because we have the sustainability is more strict because we need to follow the ISO process. I think that there it will be more difficult to have that penetration of AI. At least I don't see it to come very early. But in terms of predicting the toxicity properties, I think that there is a lot of room for AI. And especially when we try to combine the different kind of bioassay data.
Could you mention some methods that you believe that are going to be promising in this area? I mean, foundational kind of models, not that much the regression models that we have been using in the past. Can you mention methods that you believe will have an impact or a potential for assisting the SSBD kind of application in your territory? I mean, you mentioned one, the NLPs,
No, but I see that also the more traditional machine learning methods like artificial neural networks, for example, at least the more complex artificial neural networks can have this use. I see that agentic AI can be very, very useful in the sense of SSBD because actually it can help it can guide the user on the different methods and data that you should use. So I think that in 3-4 years, we will have this capacity to move in this direction, to use the agentic AI to guide us through the innovation process.
Very nice. Thank you very much, Spyros, again, and thank you, double thanks, for the speed.
Thank you very much.
And I think it's time to introduce Leah Hernandez. So Leah, please welcome. Leah Hernandez is representing National Institute for Public Health and the Environment. She's an expert in applying the safe and sustainable innovation approach. So you see, innovation comes, as in the case of Sophie, very
It's the wrong screen.
Yeah.
So let me go back to the agenda. So really, and because of the time, really setting the scene, talk about why it's SIA and not safe and sustainable by design, and then share some reflections and outlook. So what is setting the scene? So I think it's really important to the why. I always start my presentations with why are we talking about this? And I think it's important for us to realize that when you look at the planetary boundaries, that we are operating outside 6 of the 9 planetary boundaries. And if you see the trend from 2009 till now, we started just, crossing 3 in 2009, and now we're in 6. So you can really see the pattern that our planet, we're operating outside the planetary boundaries. And we are really having this very visible. If you look at last year, all the extreme weathers we saw in Europe, there was a combination of drought, floods, fires, hailstorms all over in different parts of Europe. So these extremities in weather are really a reflection on of this pattern of operating outside the planetary boundaries. But I think it's really important that we understand that anything that we do in terms of world impact has to be global. Because if you look at this little chart, that you look at where Europe is in comparison to China and the US, that is really important. That's why in the OECD, where it's very global, that we gather efforts at a global level. Another aspect that I know Andreas mentioned in the first presentation is that we see this increase in advanced materials. They're really seen as the future and the solutions to many of the sustainability issues that we are facing. And finally, the complete change in the Commission. There's a different accent in the Commission, and it's more drifting in the direction of competitiveness. So we really need to shift the work that we do in balance with competitiveness. But what does this mean as a whole? And I think what we really need is a new mindset and processes in the way we think and the way we innovate. If you look at this triangle this is from the Chemical Strategy for Sustainability and the Zero Pollution Action Plan, that we are no longer interested in eliminating or minimizing, that we really want this preventive. That is really important important that the mindset is a preventive mindset, not a remediating mindset. And also the core values of the things that we do are do no harm to man and the environment. And this is where safe, sustainable, and circular really come in place. And the observation that everything that we do early, start from the innovation process, has the biggest impact. And this is where, we have this ambition to go and move towards safe and sustainable chemicals, materials, products, and production processes. And this is reflected. I'm going to really move really fast on in the EU policies and regulation, because now we have, for instance, this new Critical Raw Materials Act that we really want to be strategically autonomous, and that's really important that we take care of the materials that we use. We are currently in the middle of a REACH revision. The REACH, if you don't know, is the chemical legislation they're really looking at new endpoints such as endocrine disruption and these persistent substances. From the sustainability aspect, there is a new regulation called the Eco-Design for Sustainable Product Regulation, the ESPR. And here we are looking at, working on a digital product passport to really have traceability on the different products. And here you're going to be looking at factors such as product durability, reusability, upgradability, energy, recycled content, carbon footprints, and waste. And finally, from a business perspective, the CSRD, which is the Corporate Sustainability Reporting Directive, which will look at more the social aspects and really look at how companies have and integrate sustainability in their corporate strategies. And if you think about a safe and sustainable by design, it kind of takes into account all these different aspects and prepares companies for the upcoming regulations. The other aspect, the accent now in Europe is industrial leadership and this transition pathway. And we're not doing this alone. The Commission is really working together with CEFIC. I'm glad Sophie is here in this EU industrial transition pathway. And this is really a co-implementation process. So we're starting to see the importance of these partnerships. So I think that's really the key, because I'm going to also present Iris how we co-create with different stakeholders in order to make progress. And the key here is that there's urgency and we need efficiency. So those two things have to go hand in hand, and they can only be possible with co-creation with the different stakeholders. Another report that has really shifted this competitiveness is the Draghi report, and really is in what he mentioned in his report is that we need to really move towards sustainable competitiveness, economic security, open strategic autonomy, going back to the Critical Raw Materials Act, and fair competition. And he really highlights sort of 3 areas of action, which is to close the innovation gap. So really, especially to compete with US and China, to really have a joint plan for decarbonization and competitiveness, and to increase security and reduce dependency. So these are the key aspects or accents of the Commission at this particular moment. And this is being supported by other reports from Manuel Heiter. He's from the former Portuguese science minister. This idea that we need to align all and harmonize policies, we need to act really to meet the societal challenge and accelerate. And that is through investment. So the idea and the goal is to really move towards this integrated and responsive research and innovation ecosystem, again, for European competitiveness. And finally, the Clean Industrial Deal, which is almost a replacement of the Green Deal, that really looks at 3 key objectives: to decarbonize industry, to enhance competitiveness, and to lower energy costs. But this is setting the scene of where safety and sustainability needs to come hand in hand with competitiveness. So when I move a safe and sustainable innovation approach, this was a concept that we developed maybe 10 years ago in the projects that Andreas mentioned in NanoRec 2. And it was really the idea that we're, as regulators and from a policy perspective, we're always lacking behind. We cannot keep pace with innovation. So the safe and sustainable innovation approach really is the combination of the safe and sustainable by design concept, which I will describe, which is just the integration of safety and sustainability aspects in the innovation process, and regulatory preparedness, where regulators have also a role to play, that this is a joint commitment. And that it really, from the regulatory perspective, is this anticipatory accent. And it's really to make sure that we act in a timely manner. And this is facilitated by this trusted environment. And in collaboration with the NSC, in that report with the roadmap for advanced materials, it was very clear that it's key for regulators to become aware and understand innovations in an early phase, for regulators to take appropriate action, so that they can have the regulatory tools, and also dialogue. Because if you have innovations, whether they are innovations at the material chemical process or as innovation in a new test system or test method, it is essential to have this trusted environment. I know, for instance, in the new approach methodologies that were mentioned by Spyros, in the ECHA report, in the workshop they had last year, they call it safe spaces. So there is this acknowledgement that if you want to move things, accelerate them, you need this trusted environment. And what we need is really a systematic approach, these anticipatory approaches to really look ahead, be proactive, to look at the regulatory challenges, to have these trusted environments, to have a place to exchange information, and to have a monitor to see, as from a regulatory perspective, are we doing things right? So this is sort of the policy. I start with the policy before I shift to the safe and sustainable by design concept. So in terms of a story of the policy context of SSBD from the Commission's perspective and from the policy perspective, really started with the Green Deal and having these ambitions for zero pollution, climate neutrality, and a circular economy. And the idea within the chemical strategy for sustainability is to phase out harmful substances and substance of concern, to really have this life cycle thinking, which is a very new, to really boost the development and uptake of innovative, safe, and sustainable chemicals across sectors, and to attract investment into safe and sustainable products and production, really linking the work to the clean industrial deal. But that is the genesis of the safe and sustainable by design. It really is a key element of the chemical strategy for sustainability to drive innovation. What, in terms of history, you can look into the SSBD website in the Commission. They really started with a report creating an overview of all the safety and sustainability frameworks and methods. In 2022, you can look at this report because it's an excellent overview of all the tools and methods and approaches, followed by the framework, which I will present in the next slide, a recommendation that gives recommendation to member states and academia and also different actors. And then they tested this framework in different case studies in the next report. And finally, last year, we have the methodological guidance that helps to support the framework. So what is the framework? So I will present the not updated framework, but the framework as it is with the scoping analysis in the methodological guidance. So what is it? So really, it really starts with these key questions of why, what, who, and how. So in terms of the why, you start with a system definition. And here you look at which problem do you want to solve. You look at the chemical material, the process, and the products, and these three pillars are seen throughout the framework. So when you have this big picture of the value chain, of the system, or the application that you want to, where there is a problem where you see you want to solve, then you come in with these strategies that in the framework are more the principles that you look to see at in which area of the molecular process or product do you want to have an innovation so that you can have an SSBD strategy. So that is the what. The third step is that you look at the life cycle. Who in the life cycle do you need to really have this understanding of where you are in the life cycle? And finally is the assessment, which is, a combination of steps 1 to 3, which is it's risk assessment, and steps 4 is more environmental sustainability, and 5, the social and economic. And the highlight here is that it really is this holistic approach. And the idea is to integrate safety and sustainability into the innovation process so that you have, from the industrial perspective, a fail early, fail cheap type of strategy. It looks at the life cycle and it's from the beginning of the innovation until the end. Given Spyros' talk, I won't go very into the technical, this is part of the methodological guidance, but really reiterate that early innovation, in the early stages of the innovation process, you have very little information. So really you rely on these in silico tools and the physical chemical characteristics in silico tools, and you move into in vitro and maybe smart in vivo studies if necessary. From the LCA perspective, is this idea that you start very simplified, these sort of big picture, really looking at the basics. You know, are you using critical materials? What is your water, energy, solvents, waste? What does your end of life look like? And then you streamline it from a qualitative point of view to a semi-quantitative and then a full quantitative, and you move this. But like I said, I think Spyros spoke enough about this, but this is also the idea behind the scoping analysis and the framework. So what is different about SSBD? And I think it's a key aspect is this innovation thinking that in business as usual, what you have is that you have an innovation and you have a functionality. And once you're ready, that you have a prototype, then you start thinking, okay, how do I get it to the market? And what SSBD really tries to do is that you want to connect and integrate sort of safety and sustainability along the innovation process. And you see this thinking in the CEFIC that was presented by Sophie, but also in the JRC, that is really this iterative process along the innovation. And you start with a simplified assessment and move along in an intermediate assessment and then a full assessment. So really now I'm going to introduce a little bit of IRIS, all the work that we've done in IRIS to really support SSBD. And one of the things that we really faced early on 3 years ago when the project started was this common understanding, because you saw different perspectives of what SSBD is and also how to apply it in a practical perspective. So what we did in IRIS is because in IRIS we have the representation of 7 value chains, and we really try to co-create and see, we did a really literature analysis, and with the value chains try to see what are the differences in terms of safety, in terms of sustainability, in terms of circularity of not only the JRC, but the European Environmental Agency, the OECD, CEFIC, and ChemSec. The report is here, so you can take a look at it, but really to see a common understanding. That was our first step that we did. So you can look at the publication to get more details. But like I mentioned before, in IRIS, the strength of IRIS is this really strong link to industry. We have there 7 value chains represented in addition to CEFIC. And this really is the driving force, because really we are supporting this sort of science policy industry interface that is so needed so that we can have the impact and the urgency of the speed of this transition. The other thing that we did with the value chains is we tried to look at what were the building blocks that really broader than just the content and the safety and sustainability aspects. We wanted to look at what were the building blocks. So from the outside circle coming in, that SSBD has to be integrated in the corporate strategy. So in the way the company's values, that is, and all the strategic decisions. The second was that a strong risk and sustainability governance was needed. So that, for instance, very simple, link innovation to regulatory affairs and R&D. So really linking, or even the corporates. So having these teams co-create together, this interdisciplinary co-creation in the innovation process. Competencies are extremely important. This multidisciplinary bridging between safety, which is environmental and human, and then sustainability, all the different dimensions. We looked at environment, social, and also economic, and data that we've discussed today as well. Fair data, how do you manage the data, and how do you optimize it? So those are the key aspects. And again, this innovation thinking. We also found that this process is not just at the burden of industry, that this needs to be co-creative, and everybody has a special role to play in this system. The policymakers need to define and implement sort of this voluntary approach. and really and also make sure that this is also adopted globally. Otherwise, we don't have competitiveness. From the regulator perspective, to really be open to more new approaches and novel predictive approaches so that there's benefits to be able to apply these early in the innovation. For science and industry to provide the knowledge, data, and tools needed. For academia and related institutes to provide high-quality training and education for SSBD. Society needs to demand safe and sustainable products. They need to drive also the market. And for industry, this is as industry-driven and implemented in a synergistic way. But as you see, it's all the stakeholders play a role in SSBD. We then in IRIS developed this roadmap because of time, and I want to stay within the time. You can take a look at it at the publication, but we really identify what were the key research needs, the skills, competence, education needs, and also the knowledge and information sharing needs. At a high level, you can take a look at it, but really things from having a common understanding, creating this ecosystem, thinking, and also the role of investments to support and drive and have an incentive for industry. So now the regulations are we call them sticks. So they are really, to drive, they are needed, but you also need carrots, you need incentives. So how do we incentivize? How do we combine the policy tools to drive this to practical applicability by industry? Competencies are extremely important. You need to embed SSBD thinking in curricula mainly for material scientists, engineers, product designers, thinking about, okay, what is the safety of what I am working at? What are the sustainability? How much energy am I using? How much water is the process? How many solvents am I using in the process? What is the waste? What does the waste look like? Do I produce a lot of waste? What happens to the waste? Am I using toxic substances? All these key questions are so important that the innovators ask themselves, move towards responsible innovation and also consider non-material alternatives. Do we need chemicals? And service-based approaches. And this soft human skills essential for co-creation because you need to bridge the different disciplines, but also the common language between, for instance, the safety and the risk assessment with the sustainability and LCA community. There's huge it's the same term can mean something different in the other community. So there you need these soft skills. What are the benefits? So I know I'm running out of time, so I'm going to go through fast. I think one of the things that we've learned in the last and this year really is to change the narrative of SSBD, to really share the benefits. And in terms of this, for innovation, we want to foster breakthroughs in products that are more safe and sustainable, but also offer improved performance and reduce environmental impact. From a regulatory compliance perspective, really future-proofing operations and being prepared for all the upcoming regulations that are coming, to have market leadership, risk reduction, also minimizing the use of toxic substances, phasing them out, really looking and giving a market for safer and more sustainable and circular alternatives, and economic viability, socioeconomic impact considerations. Really, this balance are necessary. And in order to ensure that these innovations are not only safe and sustainable and circular, but have a market. And that is really a key where policy really need to talk to industry to see how we create these markets and how do we compete globally with these innovations that are safe and sustainable and more circular. The key aspect of IRIS really is the science policy industry interface. We need them all. We need the science, the breakthroughs in science to have support policy, but to have industrial uptake. And that is where IRIS is trying to play a key role. How do we get industrial uptake? And it's only through this co-creation and in order that in bridging this connection of this interface that we're going to make it. So what are my concluding remarks? So urgency, we really need to take action. Like I said, we need this efficient science policy industry interface, that your science has an impact beyond a publication, but actually for industry or to support policy. Industrial uptake. And we need to find an extra attention to competitiveness. It is no longer only safety and sustainability. You need to have performance and competitiveness, and this we need to do together. And please join us in the IRIS community, because we can have these great discussions on how we can achieve all these goals together. So this is, the QR, and there we have all the 7 value chains, and it's a community where we have these discussions and try to move the field forward. Thank you very much. I hope I stayed to the time.
You've done perfectly. Yeah. Thank you very much for the talk. I no questions. Thank you very much for the talk. It has been great. I mean, I would like to probably get one question from my side, getting back to your framework that you nicely explained. You mentioned data. We already touched on that. I don't want to raise this as an issue. You point the importance of that. My question is more about the possible KPIs. It's probably a difficult question. We're trying to get answers for that. So I try to get some assistance from your experience. Let's say if we want to try to quantify the SSBD, try to get some KPIs, for the SSBD performance, how you would quantify innovation in this kind of, in such an approach?
That is a really
or how you...
Yeah, it's a difficult question, because innovation is a moving target. And
No,
I think
to explore, your definite thoughts around that. Yeah, sorry. Yeah, go on.
Yeah, like I said, it's a difficult question, because we are in a transition, and that means that we want this mentality of tomorrow better than today. And also that innovation is fast moving. And I think you cannot, to have KPIs for innovation, the companies will not share the innovation. So it's very difficult. I think maybe Sophie has more, she is in the innovation arena, and she can give you, but I don't think that it's very difficult to quantify. The only thing that I see the movement now is with the ESPR, is that you have these reference materials, and you mentioned the PEF, and you mentioned these product categories. And with the ESPR, what is happening is it started in energy, and now they're moving to textiles and batteries. And what you have there is, which for each product category, you have a type of baseline. So what I see is that using that baseline, you can move the field forward by having these sort of, goals, whether they're energy goals or decarbonization or, removing the substance of concern. I mean, PFAS is a huge problem in many sectors. How do we eliminate them? Or these types of substances. So I see that type of strategy, but I don't see a KPI in any other way, because innovation, like I said, is a moving target. But I don't know if maybe Sophie, you have other thoughts on the innovation side on how to do this.
Sophie, would you like to pick up on this?
Well, it's indeed a complicated question. Because innovation is about, basically having new product or new process on the market. And in what we're covering here, it's about chemicals and materials. So it can be innovation in all dimensions that we have mentioned. Very often it is driven by performance, but this can be performance of during the use phase. This can be performance of during the production phase in terms of environmental impact. So this is initially linked, but measuring, exactly as Leah mentioned, we can evaluate the improvement based on some KPIs, but innovation is multi-factor. So it's there is, to my knowledge, no real evaluation of innovation as such.
And I don't think it will work, because I think you want to keep that as you don't want industry. It has to be industry driven, and policy has no business there. And I think that's how you need to keep it. And I think what the Commission really is trying to do is provide a framework that can guide innovation in terms of how do we include the safety and sustainability. And like you said, there could be innovations in for instance, machinery that I saw this week in the ETP Textiles workshop, these machines that can make digital twins. I think maybe what you can also think about is how digitalization is going to revolutionize the way we innovate. I see these material acceleration platforms. It's a new way of material innovation. I think maybe there's a huge opportunities that we can really move the field forward of innovation, but also of safety and sustainability when the fields come together. But I think we're also in a transition of all of them coming together. There's still silos in Europe that we're now with SSBD is bringing the fields together, the innovation field with the field of safety, with the field of sustainability. And I think that would also have huge impact in the way we innovate. But I don't think KPIs will be, I don't know, I don't think there'll be something that we will look, maybe in the 10 years, maybe, I'm not sure if how the field will with digitalization. And the other one is the digital product passport, because then you have traceability. And if you want to measure something, that could be another place where there could be maybe room for some KPIs to move industry towards safer and more sustainable practices.
But I think, Leah, allow me to say that if we want SSBD to really grow, we have to think of KPIs, and things, where we can measure things, otherwise it will remain very qualitative, as a framework. So this is why I insist on this KPI. And since I have you both, let me explore one other direction, which, for the people, who try to develop KPIs, there are open questions like how you weigh the different stakeholder groups, because stakeholders participation is another different thing from LCA. You have SMEs, you have large companies, you have commercial groups, you have communities. How you weigh the different, participation of these groups in the SSBD framework? I mean, which is probably like the social LCA type of aspect. Probably it's an open thing. Am I right?
I do think so. Yeah, maybe I also join in the discussion. I have enjoyed a lot your talks, and I also noticed reviewing articles for high performance journals, high impact journals, that these high impact scientific journals related to chemistry are now requesting scientists to make life cycle assessments. And what I see happening is that a chemist is sometimes making a life cycle assessment of their laboratory experiment. This doesn't make any sense at all. I think what is very key is that we connect the people that are capable of doing life cycle assessments, that are capable of doing social life cycle assessments, with chemical engineers and chemists to make together these assessments. I think that's very important.
But Boelo, life cycle assessment in the lab doesn't make any sense to me. I don't know what exactly the journals say, but life cycle analysis is cradle to grave kind of thing. So unless you consider upstream and downstream kind of implications, I mean, a gate-to-gate type of analysis is way too limited to be considered seriously. But yes, I think SSBD...
This is also the interpretation of the authors that want to publish their work in this journal. So these authors have not understood the concept of life cycle assessment. That is basically my assessment of the problem there.
So you have a question for the ladies, for Leah?
I don't have a question. I just wanted to add this and to emphasize how important it is to connect the different communities. That I'm very happy to see all of you here in our EFCE event, because that is highly important, I think.
And if I can say one of the good practices, and the one thing, especially early innovation, that has worked in all the projects that I work on SSBD, is this co-creation with all the expertise, is having the material scientist with the safety assessor, with the sustainability expert, with the engineer, because that the co-creation, and it's not a method or a tool, but it's the knowledge, the expertise that and the co-creation. And I often also see the problem with the LCA in the terms of system boundaries. Like I've seen many examples, for instance, that particularly in my knowledge that I know in the energy sector, where you have innovation in an anode or a cathode, and then you say, well, yeah, that anode is sustainable in the sense that it really, you use less critical raw materials, energy efficiency, but when you look at the big battery, it's still a very unsustainable battery. You still have, so I think it's also as a community, how do we set these standards for this life cycle thinking? How do we, so when I start SSBD, I don't start from the material, I start from the big picture. In IRIS, we've mapped the big pictures of all the value, what are the key hotspots of all the value chains? So you innovate for purpose. So you know that if you're in textiles, it's water, it's process. If you're in energy, it's critical raw materials, it's end of life, that you know where you're going to direct your innovation. It's a very different question than if you have a material and you just want to apply it somewhere else. It's really looking in a different way. And hopefully with these types of, like you said, bridging the communities together, we're able to do that and move the field forward to this life cycle thinking, and also to have impact, because otherwise we are innovating, but we're not making an impact, at least for the environment, which is so necessary now.
Thank you so much, ladies. I mean, just to make sure that we don't forget our audience here, I see two questions from Antonio Martins. He has been very active today, so thank you, Antonio, for giving us all this feedback. Okay, a lot of tools being developed as the SSBD will be applied by SMEs. Well, it can be applied by others. Are the questions of easiness of utilization and training being taken into account, as SMEs have limited resources and costs matter? So it's a voice from the SME community, I guess. Yeah. We have something to say. Probably, I mean, Leah, you want to say something?
Yeah, I think that's a key stakeholder group that we hope that the PARC toolbox will provide answers to. But we also need a more coordinated action. There are too many projects being developed and the knowledge stays in silos. We need to bring our work together and really put it in one place. I struggle to keep up, and I'm the expert really in all the fields looking at connecting. So I think it's an outreach to find a place that we can connect so that SMEs actually have the tools. And we do have training. So through IRIS, for instance, there's training through NSC, there's training. There was just the Venice training school as well. I think there's a lot of organizations that do have training. It's just more, how do we reach out to the SME community? They are currently struggling. There's not enough time. And a lot of them, they don't participate in these things because they are too busy just surviving. So I think it's also really having an outreach through different organizations to see how we provide that training. I know via CEFIC, there's the LRE, which is great to have all the tools. I know the OECD has a SAT toolbox. So I think it's just bringing everything in one place so that it's easily accessible if they need these tools. But an organization and coordination is needed. Yeah. I don't know, Sophie, if you want to mention you have more experience with SMEs than I do, but these are just my observations.
Yeah, well, actually, I mean, most CEFIC members are more large corporate, but this is also something that we're discussing indeed, that as the implementation of SSBD, I mean, is already challenging and resource intensive for large companies. I mean, for SMEs, it's even much more difficult because they do have less resources, basically. So we really have to take into account this, resource intensity that I mentioned when applying SSBD, and therefore this need to have access to relevant tools and data. Yeah, this is and supporting SMEs would be crucial. Yes.
So I think we are running out of time. I mean, I really enjoyed, the session, and I would like to especially thank our speakers today. I remind you that we have another session for the sustainability section tomorrow at the same time. So you're all welcome, to participate. It's going to be more supply chains. And with that, I don't know whether, Martin, you would like to add something, as a comment.
No, thank you, Antonis. So thanks to all the participants to come to this webinar. And if you want, you can share the link with the record of the webinar with your network. And it will be online, I think, in 1 or 2 weeks.
Okay.
Thank you.
Thank you again, all of you. And have a nice rest of the day. We wait for you tomorrow. Yeah? Okay.
Thank you very
Thank
much,
you very
all
much.
of you.
Thank you.
Thank you.
Bye.
Bye-bye.